Our topic for right now is going to be dealing with a ratio. Now, a ratio compares two quantities that have the same units. Now, it also could maybe be like similar units. For this sake of argument, let's say if we were doing a student to teacher ratio. Student and teacher are not exactly the exact same unit, but they're dealing with people. So again, that would be consistent with the fact of being technically called a ratio. One thing to note is you want to have actually three ways or three options that you can express a ratio. You could actually say A to B and actually put the word TO. You could actually show it as our favorite thing, the fraction, or A, and believe it or not, with an actual colon, B. So if we had a student to teacher ratio of 18 students to one teacher, that again, student to teacher is different than teacher to student. So the order makes a difference. The other thing to watch out for is to make sure, very last thing that burns in your head, is it reduced? In other words, simplify. If you're thinking fractions, you might think is in lowest terms. That is something you always want to keep in your mind when you're dealing with a ratio. For instance, let's say you have 30 yards to 12 yards. All right. Now, that's a 30 to 12 ratio. You wouldn't want to leave that as a final answer. We could divide both numerator by 6 and the denominator by 6. Remember, not just that it divides, but it's the same number that divides the numerator and denominator. So you end up with 5 over 2. So it's a 5 to 2 ratio. And again, you can express it in either of the three forms. One thing to note, a little bit different than when we would have fractions. If we had the ratio 18 cups to 3 cups, well, we would have it as 18 over 3, and then we would try to reduce. Both numerator and denominator can be divided by 6. So, or excuse no, by 3, sorry. So you get 6. So you divide numerator by 3. 18 divided by 3 is 6. And 3 divided by 3 is 1. Now, when you do that, we might have thought back in our fraction days, we would have left the answer as a 6. But we can't when we're dealing with ratios, because ratios compare two things. It's a 6 to 1 ratio. You need the 1 here, not optional. Again, you need two things to compare it to. So it would be maybe 6 cups that you drink for every 1 cup that I drink, something of that nature. But again, you need the 1, all right? So keep that in mind. This is one little technicality that you have to watch out for. The other thing here we're going to talk about is applying that knowledge of a ratio. Here we have the fact of, let's say it's you versus me. You can hold 60 pounds, and I can hold and carry 90 pounds. If we wanted to get the ratio of how much you can carry with how much I can carry, that would be 60 to 90. Again, you did 60, I did 90. But we can actually try to simplify that, try to make it get a little more quicker number recognition. And you can see if we would divide both sides by 30, or not both sides, but top and bottom by 30, 60 divided by 30 is 20. Divide the bottom number also by 30, you get 3. So you'd have 2 to 3. Again, you could show it as a fraction or with the word 2 or with a colon. Different situations would maybe probably prompt you to write it in different manners, but all three technically mean the same thing. This is really good because notice how there's no units, and the fact that that would mean that if you carried 2 ounces, I would carry 3 ounces. If you carried 2 tons, I'd carry 3 tons. You're able to extend that knowledge or shrink it down just based on that one simple fact. So again, ratios, remember, you're comparing two things of the same units, so you won't see any units as you go through and simplify. Always let that be the last burning question in your head. All right, and remember, keep practicing.